There is a quiet moment in life when the body stops shouting and starts whispering. And most people miss it, not because they are careless, but because the world teaches them to ignore subtlety. Yet the human body has its own language, older than words, written in pulses, fatigue, breath, and silence. And if you are over 60, learning to listen to that language is not just wisdom, it is survival. Because what often saves a life is not the dramatic collapse, but the small deviation that arrives weeks or months earlier, disguised as normal aging. There are moments when science feels almost philosophical, when a single symptom is not just a symptom, but a signal in a vast biological conversation. And if we pay attention carefully, we find patterns, 5 patterns especially, that repeatedly appear before serious health crises. The first is a shift in energy that does not match effort, and it is one of the most overlooked signals because it disguises itself so naturally as just getting older. But biologically, energy is never a vague feeling. It is a measurable outcome of countless systems working in coordination. The heart delivering oxygen, the lungs exchanging gases, the mitochondria inside cells converting nutrients into usable fuel, and the endocrine system regulating balance across all of it. When any part of this chain begins to weaken, the result is not immediate collapse, but a subtle mismatch between what you do and how your body responds. You might notice that simple tasks begin to feel disproportionately heavy. Walking a short distance, speaking for a long time, or even sitting upright for extended periods begins to require a kind of effort that feels unfamiliar. The important detail is not exhaustion itself, but the absence of recovery. Normally, fatigue has a rhythm, exertion followed by restoration. But in this case, rest does not fully restore what has been lost, as if the body's internal recharge system is no longer reaching full capacity. From a physiological perspective, this can reflect changes in cardiac efficiency, where the heart is still functioning but less effectively delivering oxygen-rich blood to tissues. It can also point toward metabolic shifts, where glucose is not being processed as smoothly or mitochondrial function is declining at a cellular level, reducing the body's ability to generate energy even when nutrients are available. The nervous system may also play a role, altering perception of effort so that normal activities feel heavier than before. What makes this phenomenon particularly important is its subtle progression. It does not arrive as a dramatic event, but as a gradual widening gap between intention and response. You decide to do something simple, and your body responds as if the task is larger than it is. Over time, this gap becomes the new normal unless it is recognized. There is also a psychological layer intertwined with the biological one. When energy becomes inconsistent, the mind often begins to adjust expectations downward, assuming limitation rather than investigating cause. This can mask early warning signs even further, blending physical fatigue with behavioral adaptation in a way that feels deceptively ordinary. The second is a change in breathing during stillness. And what makes it especially significant is that breathing is one of the few bodily functions that is both automatic and consciously observable, which means the body often reveals its internal state through it long before pain or obvious illness appears. And when that pattern begins to shift at rest, it deserves careful attention. In a stable physiological state, breathing at rest should feel almost invisible, a quiet background rhythm that does not demand awareness. The lungs expand and contract efficiently, oxygen is exchanged without effort, and carbon dioxide is removed in a balanced cycle regulated by the brainstem. But when this equilibrium begins to change, even slightly, the experience of breathing becomes more noticeable in moments where it should not be. A person may begin to feel that sitting quietly requires a subtle awareness of breath, as if the body is asking for more oxygen than expected even without physical exertion. This can reflect early changes in the cardiovascular system, where the heart is working a little harder to maintain circulation, or in the respiratory system, where the lungs are not exchanging gases as efficiently as before. It can also relate to shifts in hemoglobin levels, subtle inflammation, or fluid balance within the body that affects how oxygen is transported and utilized at the cellular level. What is scientifically compelling is how sensitive the respiratory system is to internal imbalance. Even minor disruptions in oxygen delivery or carbon dioxide removal can alter the subjective feeling of breathing without producing dramatic external symptoms. The nervous system responds to these changes by increasing awareness of breath, almost like an early warning mechanism designed to draw attention to internal stress. There is also a neurological dimension, where the brain's interpretation of breathing can change under conditions of fatigue, anxiety, or metabolic strain, making normal respiration feel more effortful than it objectively is. This creates a feedback loop where awareness of breathing increases, which in turn heightens sensitivity to it, even in calm environments. Over time, this shift can become so subtle that it is mistaken for normal aging or temporary tiredness. Yet physiologically, it represents the body adjusting its baseline in response to underlying strain that has not yet declared itself in more obvious ways. The third is confusion that comes and goes, small lapses that feel like distraction but are actually fluctuations in oxygen delivery, blood sugar stability, or neural signaling. And what makes this particularly important is that the brain rarely fails in a dramatic or linear way. It instead shifts in subtle inconsistencies that can easily be mistaken for normal forgetfulness or momentary inattention. In a healthy state, the brain operates with remarkable precision, maintaining continuous communication between billions of neurons through electrical and chemical signals that depend heavily on a stable supply of oxygen and glucose. And when either of these resources becomes slightly unstable, even for short periods, the clarity of thought can begin to fluctuate in ways that feel almost random. A person may notice brief moments where familiar words feel harder to retrieve, or where concentration slips during simple conversations, or where a task that was just understood suddenly feels slightly unfamiliar. And these episodes often resolve quickly, which is why they are frequently dismissed as distraction or fatigue rather than being recognized as physiological signals. From a scientific perspective, these changes can reflect transient reductions in cerebral blood flow, where the brain receives slightly less oxygen than it requires for optimal performance, or subtle variations in blood sugar levels that affect neuronal energy availability, or even minor disruptions in electrolyte balance that influence signal transmission between nerve cells. The brain is uniquely sensitive compared to other organs because it has very limited energy reserves, meaning it relies on constant, uninterrupted supply, and even small deviations can temporarily alter cognitive sharpness without causing permanent damage, which is why the symptoms can appear and disappear rather quickly. There is also an interesting interplay between physiology and perception, where the brain's own monitoring systems detect these minor inefficiencies and adjust attention levels accordingly, sometimes resulting in a feeling of mental fog or slight detachment from the immediate environment, even when everything externally appears normal. Over time, these brief lapses can form a pattern that reflects underlying instability rather than isolated incidents. And while they may not indicate immediate danger, they reveal that the finely tuned balance of neural energy regulation is becoming less consistent than before. The fourth is unexplained changes in balance or coordination. And this is one of the most revealing signals because balance is not a single function, but a complex integration of multiple systems working in real time, including the inner ear, vision, proprioception in muscles and joints, and the central processing of the brain that constantly interprets spatial position without conscious effort. In a stable body, this system operates so seamlessly that standing, walking, or turning feels automatic, almost effortless. But when even one component begins to lose precision, the entire network adjusts in subtle ways that may not be immediately recognized as a medical concern. A person might begin to notice slight hesitation before stepping forward, a brief wobble when changing direction, or a moment where the body feels just a fraction slower to correct posture after a small imbalance. And these experiences often occur without pain or obvious weakness, which is why they are frequently overlooked. From a physiological standpoint, balance depends heavily on rapid communication between the vestibular system in the inner ear and the cerebellum in the brain, which fine-tunes movement and coordination, and any disruption in blood flow, nerve conduction, or sensory input can create inconsistencies in this system long before more serious symptoms appear. Even minor reductions in muscle strength, joint flexibility, or nerve sensitivity can alter how the body perceives its position in space. And when these inputs become slightly less reliable, The brain compensates by making constant micro-adjustments that may manifest as subtle unsteadiness or increased effort in maintaining posture. What is particularly interesting is that the brain often adapts to these changes without immediately alerting conscious awareness, meaning a person may unconsciously modify their walking pattern, widen their stance slightly, or slow their movements without realizing it, all in an attempt to preserve stability. There is also a neurological dimension where age-related changes in signal processing speed can affect how quickly corrective responses are generated, making recovery from small disturbances less immediate than before, even though overall function remains intact. These shifts rarely present as sudden loss of balance, but rather as a gradual increase in uncertainty within movement, where the body feels just slightly less predictable in space. And this subtle change often serves as an early indicator that multiple systems responsible for coordination are beginning to operate with less synchrony than they once did. And the fifth is a quiet alteration in recovery. Wounds that take longer to heal, infections that linger, or minor illnesses that feel disproportionately heavy. And this is one of the most biologically meaningful signals, because recovery speed is not just a measure of healing, but a reflection of how efficiently the entire internal system is coordinating repair, defense, and energy allocation at the same time. In a well-balanced body, healing is a carefully orchestrated process involving inflammation control, immune cell activation, tissue regeneration, and metabolic support, all of which must occur in a precise sequence. And when this coordination begins to slow, even slightly, the difference becomes visible in how the body responds to everyday stressors. A small cut that once healed within days may now take noticeably longer to close, or a mild respiratory infection may persist beyond its usual duration, not because the illness is more severe, but because the immune response is less efficient in clearing it and restoring baseline stability. From a scientific perspective, this can reflect changes in immune cell production, particularly the activity of white blood cells responsible for identifying and eliminating pathogens, or it may involve reduced circulation efficiency, where fewer immune resources reach the affected tissues in time to accelerate repair. It can also be linked to metabolic and nutritional factors, where the body's ability to mobilize proteins, vitamins, and energy for tissue regeneration becomes less responsive under stress, creating a slower and less coordinated healing environment. There is also a deeper systemic layer where chronic low-grade inflammation or subtle hormonal shifts can alter immune responsiveness, making the body less decisive in distinguishing between active threat and routine repair, which can lead to prolonged recovery phases even after minor illness. What makes this particularly important is that the immune system rarely fails abruptly in its early stages of decline. It instead adjusts its threshold of response, becoming slightly slower, slightly less precise, and slightly less resilient, changes that are easy to attribute to aging but may actually reflect underlying physiological strain that is still in its early expression.